In the previous lesson, we looked at how to find volume when we're rotating an object around the x-axis. If you think about it, the x-axis is just a horizontal line, y equals 0. Today we're going to look at how to rotate around other horizontal lines, things like y equals 3, or y equals 7, or y equals negative 2. So in order to rotate around the line y equals c, we use one of the two following formulas. This one is equivalent to the disk method, where we just have one equation. So the only difference, if you notice, is that we have this minus c part right here. Otherwise, if you take that part out, it's really the exact same thing. It's just f of x squared, but this time we have to subtract c. So for example, if it's y equals 3, you just take your function, subtract 3, and then square it. Okay, or you use the equation like this, which is the equivalent of the washer method. So notice that still we square each individual piece, the f of x minus c being one piece, and the g of x minus c being the other. And we still have pi out front. And just so you know, this is one area where it's very important to focus on which one is the outer and the inner instead of the top minus the bottom. So really f should be the outer and g the inner. So outer minus inner. And hopefully you'll be able to see in the examples we're about to do what I mean by that. Okay, first example, find the volume of the solid created by rotating the region bounded by y equals 2 minus x squared and y equals 1 around the line y equals negative 1. So let me sketch this for us. There's our coordinate plane. We have y equals 2 minus x squared would look something like that. And then y equals 1 would look something like that. So the region we're trying to rotate is this right here that I'm highlighting, or shading in. What we're rotating around is down here, y equals negative 1. So if you can think about it, this is going to create a bigger volume than when we were rotating around the x-axis. Now that's going to depend on what line you pick. It's not that every time we do some other line it makes it bigger, but in this case it will. Because if we rotate on the x-axis, we don't have nearly as far to go as if we go around y equals 1. One way you could think about it is if you were spinning in a circle and holding out your arms. Your elbows are not making as big of a circle as your hands are. Or maybe it's easier to think if you're spinning in a circle and holding your hands out, your hands are making a big circle. But if you're spinning in a circle and holding on to a little kid, then that little kid's feet are making a much bigger circle than your hands are. I don't know if that's helpful to visualize or not, but anyway. So we're going to actually have a bigger volume here than if we were just rotating around the x-axis. Okay, so first thing we need to do is find the boundaries. So just like before, we will set these two equal to each other, 2 minus x squared and 1, and solve for that. So I'll subtract 2 from both sides, get rid of the negatives, and then take the square root. So I get x equals plus or minus 1. So I'll set it up and I'll do pi times the integral from negative 1 to 1. And I need to do the outer equation first. Well, if you can visualize that region that's shaded in being rotated around the red line, y equals negative 1, then clearly the parabola is what's going to create the outer edge of that shape. So we put the parabola first, 2 minus x squared minus a negative 1. Okay, or if you want, you can just call that plus 1, and that'd be fine too. Okay, and we subtract from that the inner equation, 1 minus negative 1 squared. Okay, so that's what we would have. Now let's plug that in our calculator. So give me a second so I can move this over so we can see. And then pull out the calculator. Alright. So all you can't quite see there is the pi, but it's there. So we'll actually just multiply by the pi at the end anyway. So math 9, and then we do parentheses 2 minus x squared, and I'm just going to call that plus 1, all squared. So notice I gave it its own parentheses, minus, well, 1 plus 1 is 1, so it's just 2 squared. And then comma x, comma negative 1, comma 1, and it gives me 6.4. I'm going to change that to a fraction, and it gives me 32 over 5, and don't forget to multiply by pi. So 32 pi over 5 would be our answer. So like I said, really not a whole lot different. You just got to deal with adding, or excuse me, subtracting that constant that is the line you're rotating around. So that's pretty much all there is to it. I just want to do one more example, and then that'll be it. But what I want to do is use this exact same region, but rotate around the line y equals 5. So same region as above, rotate around y equals 5. Alright, so let me scroll back up so you can see the graph again. Y equals 5 would be a lot higher, so it'd be somewhere up here, like this. Okay, now you gotta kind of use some visualization here. But if we take this black region right here and we rotate it around the green line, okay? If we take the black region and rotate it around the green line, if you notice, our black region is actually starting below the green line. So when it starts to rotate, it's going to be rotating up and then over the green line. So in this shape that we're creating, y equals 1, that straight line is actually going to form the outer edge. So this time when we set up the equation, we still have pi in front. We still do negative 1 to 1. But this time, again, look at the picture, the outer equation is going to be the 1. So we do 1 minus 5 squared minus 2 minus x squared minus 5 squared. And it's important to visualize that. As you rotate the black region around the green line, the outer edge of the shape that's created is the straight line, the y equals 1. So that's why it comes first. So let's plug this one in now. I'll move it over so we can use the calculator more easily. Okay, so let's see. Math 9. 1 minus 5, that's negative 4 squared. Make sure you put that in parentheses. Minus parentheses 2 minus x squared minus 5, all squared. And then comma x, comma negative 1, comma 1. We enter 9.6, which is 48 over 5. And then we have to put the pi with it. So we get 48 pi over 5. Okay, I want to say a couple of things about this, rotating around the lines like this. First of all, if you get a negative number, then probably what's happened is that you have put these right here in the wrong spot, and you should switch them. So that's one thing to watch out for if you get a negative number. Also, you can still do this without a calculator, figure out which one's the outer shell, if you just plug in numbers like we did before. So for example, on this one, we could plug 0 into the two functions, because that's in between negative 1 and 1. So let's look back up here. If I plug 0 in this function, it gives me 2. And then if I plug 0 in here, well, I just always get 1 with that function. So you've got a 2 and a 1. But what you need to think about is not which one's bigger, but which one is farther away from what we're rotating around. We're rotating around 5. So the thing that's farther away from 5 is the 1. So it's farther away, it becomes the outer shell. And that's why we put it first in this equation down here. Alright, good luck. The homework for that is page 428, number 15 through 18. I may also assign some AP questions from a worksheet in class as well.